Welcome to Tech Talks, or Techo Talks as we're now calling them. I am Tim Delesio and I am the CTO here at Techolution. And today I'm going to talk to you about microservices and monolithic applications, one of my favorite subjects. I'm a developer by nature. I've been developing a long time, so this is what I really care about, about the application itself, what it looks like. So before we begin though, I want to at least define what we're talking about. What is a monolithic application versus what is a microservice? So first, a monolithic application is just a collection of different things all put together. It's usually a much more bloated application. It's heavier, has a UI in it. Typically, it's just everything put all together and jammed into one thing. And these things don't start this way. They just kind of grow that way over time. And you just jam more and more and more into it, and it just gets to this big application that just grows. And versus a microservice, which is really just a application that's broken down into smaller pieces. These could be doing multiple different things or different functionality, but microservices themselves are independently features and applications that are broken down into smaller components. So now that we know that, everybody seems to be moving to the way of the microservices. So, why is that? What's the big driving factor to get there? What really is the motivating factor here? So let's go over some of the benefits here. So why would you want to go there? First, you get a lot of flexibility. You can choose the right service and functionality and language that fits your needs. So if you're doing something very specific to one language, you don't have to build your entire application landscape in it. Just pick that one thing and just use that for your actual service. And to that end, each one of these services is very replaceable. So these are all individually, applications that are usually tied together through some, interface or through some form that everybody speaks the same. But as these technologies grow, and this is a big problem with monoliths, is you start getting to this legacy and technical debt. With the microservices, you can just replace that application and that functionality to whatever you need to do. So it really frees you from that technical debt burden. They are built to scale. So if you have a monolith and you need to scale it and be able to add more load and capacity, you need to scale the entire thing. With a microservice, you can only scale what you need to. So if a certain feature in your application requires more horsepower than the rest of it, just scale that up. That makes it great. And since these are all decoupled, you can actually have a lot of speed in your deployments. So they're less intertwined, they're less connected. So as you complete them and ready to push them out, you can just release them as you need to. And since they're all broken down, you get a lot more organizational alignment within your particular organization. So if you want a team just focused on, login, for instance, or focused on, your shopping cart, you can have these services aligned to the actual organization. And finally, we design them for failure. We all know in application development, things break, things go down. So why not build from the ground up, knowing that it's going to go down, and design for it? These are a lot of the main reasons why people are slowly starting to migrate all their application stacks to microservices. But doing so is very challenging. Not a free lunch, as they say. If you look at this slide here, you may or may not know what this is. This is what I refer to as the Death Star of Netflix. So this is all these dots on the outer circle are all the microservices that they have running. And this is probably a little bit dated, but still kind of paints the picture. And then every line in there is a communication point between these microservices. So just imagine how many services they have running and how all these communication is connected. And this is a very, very complicated system. And as you get into these distributed systems and distributed networks, you find systems like this where they're all interconnected and having all these complexities and whatnot. So just managing these from the development perspective and from the operational perspective it's a challenge. How do you make sure that service A is calling service B and all this interconnectivity is actually working? Which kind of ties into my next point. You need a very good DevOps-friendly operation and mindset in order to do this. These all require lots of automation, lots of process. You can't just go out here and expect everything to run. It has to have an orchestrated view. It has to have all these great pipelines that interconnect it and automate a lot of these pieces. Think about when one system has a problem. So, how do you figure out where that problem is? Where is the error? Where is the log file that even the system happened? So if you don't have tools wrapped around this, it's going to be very, very hard to get these systems out. And then imagine if you're a developer. In the old days, on a monolithic application, you want to test and deploy your apps. As long as you got a fairly beefy machine, you can spin that up. But imagine if you had to deploy every one of these services onto your local computer. I mean, there probably isn't a system out there that has enough RAM and CPU in order to even get all those systems out. So how do you get up an environment? How do you test all this stuff? How do you make sure it works all together? So couple all these things together, and it's a challenge. So how do we get through this? How do we fix this? People use microservices, so obviously there's a way around this. So Netflix, I give a lot of credit to. They came up with a lot of these frameworks and a lot of these patterns and a lot of this work to actually get above and fix some of these problems. So first, we need a way that we have the service discovery. So think of service discovery as similar to how IP works in DNS. I mean, if you were in a world where you had to remember every IP address of every system out there, I mean, the internet would not be where it is today. The same idea here is for service discovery. If your service needs to call another service and needs to be able to access that information, it just looks up that service in a directory and finds out where it is and points to it. That way, if the internet goes down for that service or it's replaced, I mean, everything's disposable in the internet. So you need to have a central catalog of all your services that you can go to and find out which ones are available and which is offline. This allows us to give us those pulses and heartbeats and things like that to make sure that they're actually responding. And then, when things go wrong, I mean, because things, again, you were building for failure, right? Make sure that they don't bring down the entire system. I mean, if your system is dependent on another system, which is dependent on another system, and you get that cascading effect where that end system fails and everything else, falls down in front of it, and then all of a sudden connections start to stack, you need a way to prevent that. And that's where circuit breaking comes in. Think of your circuit breaker in a house, right? You trip that circuit and your house doesn't burn down. Just that one circuit is offline and not working. So same concept on the software side. Then things like bulkheading, where you want to make sure that you just don't have a single pool and a single connection to a service, so that you can actually access a pool of resources instead of just a single resources. External configuration is really important as well, especially from your testing perspective. You want to remove configurations and actual call outs to your services from your code and put them in configuration files. Think of the way that one way to do it, and probably an older way, would be to essentially put or hard code an IP address of a system that you're calling into your system. But as you move from dev to qual to production, if you need to make a code change, then you're not testing the same system in all the environments. So we solve that by removing those configurations from the code and putting them in configuration files, thus decoupling your application itself that you move through different environments from the configuration that manages it. Making sure that you have tracing and logging and treating all of those files as a stream so that we can stream them to a environment where we can actually search and follow the path of where that user journey went throughout your application. And then building the fail, right? Purposely injecting chaos into your system, shutting down systems randomly, and disrupting network traffic and things like that, and really taking a good look into your system to see where your challenges and where your files will actually crash. So now that you know that, let's talk some best practices here. So where to start, and how to identify when you're doing a good job on your microservices. So first, there is a concept of nanoservices, smaller than micro. So, you never want to get to the level where, almost every method is its own service. And maybe one day in the future we're into true serverless and, all this stuff is just flowing, but if you get into having your services way too small, you're going to create problems that you don't necessarily need to have. So, microservice and creating them is more of an art than a science. You don't want to fall on that one side of macro services where you're basically treating smaller monoliths, but on the flip side, you don't want to be creating nano services where they're just really, really tiny. Second, one data source should essentially be one microservice. So if you create, let's say have a table in there, and if you have multiple microservices updating that table, that's a problem. So you want to make sure the general rule of thumb is one microservice, one data source, so that you're not having multiple configuration points and multiple entries into that. You need full, as much automation as you can get. And with TDD or test-driven development and an automation mindset, right? So when you're developing a process or flow from really anything that can be automated should be automated. And if it can't be automated, you should be asking yourself, why can't I have this automated? And there may be reasons, but at least have that mindset in there so you're doing automation first and really working on and focusing on that automation to simplify your life in the future. You want to design for failure. I think I talked about this already, but assume it will break because it probably will. So if you build that with that mindset and going in, you're really going to save yourself a lot of headaches and a lot of problems in the future. Because when it actually does break and go down, you say, hey, I tested for that. I know what that looks like. I understand the problem. As you start to deploy these two, you should almost think too as a best practice, one microservice is usually one container. Now, granted, there are some situations where that may not be true, and you may want to jumble and connect a couple of microservices into a single container, but for the most part, the general rule of thumb, make sure you have one microservice equals one container. And then, if you guys don't know what 12-factor is, you should try to adhere to as many 12-factor rules as you can. So if you don't know them, I could cover them in a different video, but go check out 12factor.net and you can read in boredom about what they are. But the main ones are, make sure your application is disposable. That way if it just dies in the future, you're not totally writing for, worried about it and can live with it. That means that it's stateless. It doesn't have a state internally in the application. Make sure all your logs are treated as streams, and there's a whole slew of these, but external configuration, that's another one. But those are really the important ones to really hit on. So you like what I'm saying and you want to get started. So how do I start? Really there's four main patterns which I've seen that work the best here. And I would say probably number one is the first one on the list, but create it, right? Just start from scratch. Create a new environment. We did a webinar recently on this, but a leapfrog approach. Create a new environment and just start porting things into that application or that new environment that really fit its needs. Things that are really built from that, as you start to, it's a new environment, so treat it as a new environment. Everything that goes into it is fresh and ready to go. Second thing, strangle it. So you have an older, bigger application, you can start carving pieces off of it and interfacing it back into your existing application. That way you're not really taking a full approach and taking that monolith and day one doing a rip and replace on it. You're slowly carving off pieces of it that make sense. If you have a somewhat segregated class or function in there that you could piece off that makes sense, start there. Just start to cut it down and whittle it down, get it to the point where you can actually work with it. Third, it would be proxy it. So this works great on like legacy systems, for instance. So if you have a mainframe application that you're running and you're really dependent on it and you really need that data in there, set up something in front of it. And that way start interfacing all the new systems with that proxy. And then over time, you'll be dependent on that proxy and not necessarily the system behind it. That gives you the freedom to pull out that system.